Okay, so I'm going to discuss the research projects that we have planned for this semester. Okay, so the research project is going to be divided into three different rounds. The first round of the research project is going to involve going into the literature, doing finding a journal to go through, just find an article that you find of interest to you, and build a presentation of that article for the class to watch. There's a separate discussion of this literature presentation that's posted. If you go to Carmen and there's like a lecture video page, that's where you can see the videos for like experiment 1, 2, 3, etc. There's just a page for lecture videos, and there's a lecture video on like this literature presentation. So you might want to check that out at some point to figure out some information on the literature review. One other document to make sure everyone's aware of is there's an experiment 6 lab handout that's about 2 pages long that describe round 1, round 2, and round 3 in a little bit more detail. So this is like a quick overview, and I'll even scroll through that handout before we finish this video too, so we can take a look at that handout. But round 1, you're going into literature, finding a journal article, and then after that, you're finding a problem worth studying, writing a proposal for that idea, and then you're preparing a presentation from there on your idea. So the idea here is you get introduced to the literature, maybe see some things going on that are being published, and then from there you can think about something you want to study in terms of research, where you're writing a proposal and then writing a short presentation or preparing a short presentation to give an overview of your plans. And so then round 1 sort of ends with that presentation where you're going to give actually 2 different and really unrelated presentations. You're going to give that one presentation on the literature topic and then a second presentation on the proposal. So then round 2, you actually do your computational chemistry calculations. Hopefully you will have gotten some feedback by now. So the idea is you do that first round, then you get a break where you go into the lab, and then you come back a week and a half later to start the next round of the project, where you're starting your computational calculations, analyzing your results, preparing like a group meeting presentation. So sort of giving you an idea of like an informal style presentation where you're kind of showing your progress, what you figured out over the first couple of lab days where you're trying to actually get some data. And then you're going to write a short narrative update of where you're at with your project. Then after that, you go back to the lab for another round to then take a break from the research project. Then you come back for one final round on the project where you're completing your calculation, performing whatever your final analysis is for your project, and then writing sort of a formal presentation. So trying to prepare a more formal final presentation that the whole class will watch, and then writing a final written report in the style that's going to kind of look like a journal article. So just kind of a well-rounded approach to research through this project. Let me talk a little bit about group work. So the way groups are going to work here is that you can actually do a lot of the work of this project within a group. So we're going to let groups form with up to 4 students total per group. We're going to recommend that the group that goes into the lab together work on the project together. So if you look at the schedule, you'll notice that you're going to be with the same group of 4 when you come in to do like labs 1, 2, and 3. So if that group of 4 can work together, that's going to be our recommendation. But there's no formal requirement that those specific students work together. There's no requirement that you even work in a group. If you'd rather work alone, that's fine with us. I would rather you guys work together and try to collaborate with some of your classmates. I think you'll find that that's a more enriching experience than working by yourself. But what we plan to do next Tuesday is have everybody meet for, regardless of which experiment you're starting. So if you're starting experiment 1, 2, or 3, or the project, we want to get the class together for a Zoom session during the normal start of lecture time, so 1:15 for our class. And then 15 minutes in, we're going to break and really just let you guys, really start to talk amongst yourselves and figure out who wants to work together for those who are on the research project. We'll do the same meeting, to start round 2 for those who are starting the research project in the next round to really make sure that we're all together in the same spot at the same time, so that you can start to, ask, the other students that if they want to work together, and maybe getting a Zoom. Maybe one of you guys can create a Zoom that you guys can join and meet together and start coming up with some ideas, or maybe come up with a plan of when it is that you want to meet. One of the things I actually recommend is almost that you do that literature presentation kind of first. Maybe, and that's going to be completely individual no matter if you're working in a group or not. So the literature presentation where you find a journal article is going to be something that everybody has to do on their own. And it's really just a chance to open up some physical chemistry journals, see what's being done, get some ideas, and hopefully have some ideas flowing into the research project. So my recommendation might be that groups actually kind of like meet on that second day to really crunch together an idea for a proposal. Doesn't have to be the most solid idea in the world, just a rough working idea of some sort of a project that you guys can get started on. The handout itself will go into more detail than I will in this presentation in terms of the length and the sort of detail of the proposal, but it's just kind of a basic idea of what you want to do and a rough idea of what calculations you might do to get started on the project. So the look at that experiment handout to outline which tasks need to be or can be done in a group versus which ones have to be done individually. Just off the top of my head, the two individual tasks that that I know are purely individual, even if you're working with a group, are that literature presentation, and then the round 2 narrative is written by each individual. Some of the key things that are done by a group would be the proposal. So if you're working with, say, 3 other people, you're going to write one single proposal for everybody in the group. You're going to write one final written report for the entire group. You're going to give one final presentation for the entire group at the end of the presentation. So just look at that handout. It'll outline which tasks are done within the group and which are done individually. Work is expected to be done, in an equally distributed manner for those working in groups. If groups have issues, they can dissociate for any reason. I don't even need a reason. So if you plan, like, let's say you write a proposal with a group of 4, and for maybe scheduling reasons, you realize that you can't work with your group members. Maybe something comes up and they want to work at night and you have to work. So you say, well, I just want to use class time. So I'll just do my work by myself and I'll write my own presentation. I'll write my own final report, and then we'll just be a completely separate group. My expectations of workload are different. So I don't expect a single individual to accomplish as much as a group of 4. At the same time, I expect a group of 4 to complete more calculations than a single person. So I don't expect you to complete the whole proposal if you have to work by yourself. But just know that the workload's going to scale with the size of your group. So the bigger the groups, the more work we want to see proposed. The smaller the group, the less work that you can propose to do. Methodology: try to find a problem that you can address with computational chemistry. Search the literature to see if it's already been solved before. Ideally, we're going to try to do novel approaches, try to do things that haven't been published before. Computational chemistry is unique in a sense. Like, the easiest thing to do is to find some sort of reaction that's been studied at a low level of theory and try to study it at a higher level of theory or some other level of theory. Since we have time conflicts of how long our calculations can run, we have like a 2-hour max time limit on our calculations. There is a way to restart them that is possible, that you can do like an 8-hour calculation in like 4 steps. Not exactly ideal, but it can be done. But you can almost find something published at a high level of theory and see if you can actually replicate it with a low level of theory. I think that's a little simple, but like if you're really, like hard up for an idea, just trying to find some reaction that's been published or some sort of a problem that's been studied at a relatively higher level of theory, that would be like CCSD, big basis set, maybe like MP2 or an MP4 method or high levels of theory, and trying to do those with like HF or B3 lip to see if you get comparable results. But I think there's better problems that we can study. That would be a simple idea. I have a brainstorming slide or a couple slides later on in the presentation on really some ideas on ways to come up with problems to study. But once you kind of have a problem, you would want to do a little bit of background to see if it's already been studied or if anything's already known about the problem. Then you want to design and try to execute your experiment. Designing is a little bit, done in the proposal. Executing is then round 2 and beyond. One tiny thing you might start thinking about in round 1 would be, this is the 4th or 5th semester that we've done these projects, and we've usually done some computational chemistry. Like, since we have been in the pandemic situation, this is now going to be the 3rd semester where we've done a computational only project. But what you might want to begin with, because I find groups usually propose to do really big molecules. They want to study really big problems that we just don't have the time with our computational resources to study. So what I might recommend in your proposal is think about doing like an HF calculation, real low level of theory, with like a 321G basis set. Just pick a really small basis set and see how long the calculation takes. And just that'll give you a sense if the molecule's too big for like HF 631G star. Like if you find your HF321G calculation takes longer than 10 to 15 minutes, you're going to have a hard time using a reasonable basis set with like something like B3 lip. So you might think scaling your molecule down to a smaller molecule. There's an idea of model systems where you can, if you have like a big molecule, try to think of like how can you shorten or make the molecule smaller, but still study some relevant detail of whatever it is that you're interested in. So you might need to design your experiment, simplify what it is you're trying to do for small enough molecules that we can run with high enough theories. Then you're executing your experiment, trying to analyze the results. Try to think about how you can maybe have part of your project be a benchmarking, do something you can compare to literature values. And then some other part of your project is then, pushing the frontier on something that's unknown, where you're going to test something that you can't directly compare. It's hard to do research if you don't find something that's unknown, but it's hard to know if your calculation's on the right track. So you might think of how you can work in a model of something that's known that you can then extend to the project or the part of your project that's unknown. So we give you some feedback, through round 2, through that group meeting presentation, through the update, so you can then complete your project, present your final findings, and write your final report after round 3. Just some basic rubrics on the proposal. I don't think I want to dwell too much here, other than you can look through. We look for big picture things in your proposal. So like the purpose, content development, subscripting and superscripting using formulas correctly, citing things correctly. Like the main thing we look for is if you need a citation, do you give the citation? So like citing ideas correctly is important to do. Grammar, scientific reasoning, and creativity. Same thing with presentations, looking for essentially the same sort of idea of organized presentations, good language and delivery, supporting materials like graphs, tables, figures, central message, reasoning, and creativity. Final reports, we look at the quality of your results as one of the items. So just some basic rubrics there. And lastly is just like the brainstorming of a few different types of ideas that you might come up with. The probably straightforward ones are like structure property connections. And you can think of this from like inorganic, structures of inorganic complexes to their IR frequencies, to their energetics, to some property, maybe like a dipole moment that you can calculate. You can compare stabilities of isomers. So anytime you have isomeric structures like benzene ring structures, cyclohexane chair versus boat structures, you can compare their energies. The key is just getting into something that's not already known. We saw in one of the computational chemistry activities how you can model reaction enthalpies. So you can find some reactions that are of interest and compare their reaction enthalpies. Maybe you're going to try to compare some structure function relationship through a reaction. Like, so maybe you can study different reactions of, I don't know, just something where you have something that comes coming to my mind is like aromatic substitution and how, withdrawing versus donating substituents affect reaction pathways or whatever. Just trying to think of different reactions maybe from OChem that you might model here for their enthalpies. You can think maybe of mechanisms in their pathways. This gets a little tricky because you can model the minimum energy surfaces pretty easily. That's just using the optimization frequency calculations we've done a lot of. You can also model the maximum points, the transition states. That takes a little bit of finesse. Those are kind of trickier to find. But what you could probably do is take a mechanism where maybe you have like a two-step mechanism. So you have like your reactant to intermediate to product, and compare the thermodynamics of maybe some other mechanism where there's like 3 steps. So maybe there you're just trying to compare the relative energies without even considering yet the transition state heights of where the energetics of the transition states might look like. And you can try to get into modeling some of these transition states this way if you're interested, and we can talk about approaches for finding those. That's a little trickier, but so there's a lot of different possibilities of things that you can do. And I think the range is just of however much your curiosity and your desire to kind of learn some things maybe you don't already know how to do with computational chemistry, versus like staying, if you want to study reaction enthalpies, you can use the approaches we've already learned and then just try to find, reactions that are worth looking at. Now, some approaches for like finding like ideas to use like those ideas with, you might think towards, like reactions or structures of interest of things you've seen in OChem, inorganic lecture, etc. You could look to like research, like look to the journal articles that you're reviewing, maybe even the one you end up doing your literature presentation on, and think, how can I build a related project based upon some research paper that's already been published? Maybe you can find a computational paper and then just try to think, well, what would the next step be? Or what would some other problem that's related to that paper look like, and try to study that project. We don't really want to necessarily just replicate a project. That's like, you can do that. It's just, I think, a little bit too simple to maybe say, okay, somebody published some reaction thermodynamics calculated with CCSD. Let me try it with HF and see how good I do. Like, probably not all that exciting. So I'd rather you try to look at some extension of the work, but building an idea from some research paper you might find in the literature is a very easy approach. That's one very common that I find a lot of groups that use this approach for finding an idea for their projects. Another approach that's very interesting is if you're involved in research of your own, you could try to build your own computational project around work that you're involved with. Only little tidbit here would be, try to do something you're not already studying. Like if you happen to be doing computational research already, try to like do something slightly different from what you're already doing in your lab. Maybe use a different approach, maybe use something simpler than what your group does, maybe study a problem that's related to what you're doing, so that it's not exactly the work that you're already doing for maybe research credit for whatever research you're involved in. So now, if you're in a group of 4, odds are one of the group of 4 at least is going to be involved in research. Maybe you can think of how you can have a project related to your work. We see a lot of projects submitted with this as the kind of basis for the idea. The last idea that I have to propose is maybe think of a lab or an experiment you've done in some other class that you can adapt to like a computational investigation. So that's essentially all that I have for here to present. I might also mention just this document here is the research project handout. So this is a little bit of a different looking handout than most of our experiment handouts, but this talks about the aim of the research project. Round 1 goes into a little bit more detail of the specifics of what you're doing in the first and second part of round 1. The third part of the round is giving your presentations, getting some feedback. And the way everything's going to work here is you basically work for 2 days, give a presentation on day 3, and then your writing is due the day after the lab period after the presentation. So the idea of the presentation is get some feedback from the presentation to finalize your research proposal as the final task of the round that's going to be due then the lab period after. So round 1, 3 lab days. The start of round 2, the next round that you do after this round is when your due dates are going to be. So let's just go back to the calendar. So like start round 1, continue round 1 next week, presentation day the following Tuesday, following Thursday, this is when the writing's due. So this is when that written proposal's due. So hopefully you get some good feedback from your presentation to use to finalize your proposals. Round 2 is then described. There's a little bit of formatting that's given here. Round 2 described. I don't want to go through the reading this. We can read or talk about this more later. But then round 3 is described here, and then there's some presentation lengths here. Some due dates, etc. The only thing maybe worth mentioning is the final report, which is a little bit more detailed maybe than the other reports, is due a week following your presentations. So you get sort of an extra lab period to complete the final report at the end of the project. So just all group members contribute equally is the big key for groups. Okay, any questions on the research project? Chat post. Okay, so for the Zoom session at 1:15 on Tuesday, what I'd recommend is that if everybody could tune into that Zoom, that would be great. The lecture is not, or attendance isn't going to be required at that opening Zoom meeting, but what's going to happen is at the first Zoom, I'm just going to basically give a quick overview of experiments 1, 2, and 3 and the research project. just so that everybody's on the same page as each other of understanding what we're all up to. So if you're coming into the lab that day, if you have to come in for experiment 2 or 3, and then if you're assigned a day 1 for experiment 1, it would probably be good to come in here at 1:15 into the lab so that you're here ready to start your experiment after the Zoom meeting. And then I think you're really asking presentation day. I see your second post here. So then the presentation Zooms kind of work like this. For the day 3 presentations, the experiment 1 through 3 people get together for a separate Zoom meeting to start the session. So that's going to start 15 minutes into the usual lecture time. Let me switch to, let me go ahead and stop recording too. So I'll just say for those watching on the video later that just look on the lab schedule. That'll detail when the presentations are.